you to post that?
Yeah, so I'm going to try to post these videos. You still have to attend class if you want the points for coming to class, but if for some reason you miss or want to review stuff, I'm going to try to post these on YouTube. I can't post them on Canvas because I'd have to get them closed captioned, and that's way too much work. But I can post them there, and then we'll talk about it later. I'll show you guys how to get to that if you want to. All right, so let's get someone reading this part here. How about Jocelyn Galvin? Good.
Qualitative variables are variables that have distinct categories according to some characteristics or attributes. Gender, zip code, hair color.
Keep going.
Quantitative variables are variables that can be
Counted.
or measured. Discrete have values that are countable. Number of types money. Continuous have an infinite possibility of values between any two specific values. Real numbers from 0 to 1 temperature and are obtained by measurement.
Great. So some things to note here that are helpful. Qualitative has an L here. Quantitative comes in and that fourth letter is an N instead. I like to think of the L as standing for label, and the N is standing for number. So qualitative variables are kind of like labels. They're categorical. They're things that don't have numerical value. So things like hair color, or what else? Gender, zip code. So you might say, well, zip code's a number, but let me ask you, we are what's zip code 94551. Are we rated higher than a person with zip code 02347? No. So really our zip code is just a label that gives us a location. It doesn't have numerical value. Also, jerseys, football jerseys, right? Is number 67 higher rated or worth more than jersey number 12? No, it's just a label. Now, quantitative variables, numerical, those have numerical value, are split into two groups. The first group is discrete, the other group is continuous. The easiest thing about discrete is it has values that are countable. You can count them, like pets. You can count money, things like that. Continuous have an infinite possible, which she said that. All right, it has lots of possible values between. If you pick two values, there's an infinite number of possibilities between them. These are things you measure. So the shortcut is, if you measure them, if you measure these values, then the variable is continuous. If you count them, then it's discrete. So I would suggest maybe you circle these, discrete and countable, and maybe you circle continuous and measuring, because that might help you sort of identify them later. That's kind of the shortcut, easiest way to identify them. So again, we're going to talk about the types of variables. Data can either be qualitative labels, categorical, or quantitative numerical value. So it could be that. And then within quantitative, it can either be discrete or continuous. So discrete, let's pick the numbers 1 and 2. So say I have money. Money is discrete. And I want to pick between $1 and $2. What are all my possibilities? If I have between $1 and $2, I could have
125.
Right, yeah. Let's even be more specific. $1 and $1. I'll be systematic. $1 and $1, $1 and $2, $1 and $3, ... all the way up to $1.99. Good. There are a lot of numbers here, but there's only a fixed number of them. There's only 99 of them. It's not infinite. Now, if I was to measure between 1 inch and 2 inches, right? 1 inch to 2 inches, I could measure something, and it could be 1.1 inches. It could be 1.11 inches, which is not the same. It's different, a little bit. It could be 1.111 inches. You can kind of assume these are zeros even here if you wanted to, right? It could be 1.1111 inches. And you can keep going on and on and on and not even get to 1.2 inches. Do you guys see what I'm saying? There is an infinite number of possibilities here. So things you measure, continuous. Things you count, like money, fixed number of possibilities between. If you pick two numbers, there's a fixed number of possibilities between them. That's discrete. But again, like I said, if you focus on counting for discrete, so C and C don't go together. Counting for discrete, measuring for continuous, then you're going to kind of be in better shape. So we're going to go ahead and have you guys practice that a little bit. This is fairly important. Determine with your neighbors whether you think these are continuous or discrete. Go ahead, 30 seconds, 40 seconds, go.
The highest speed of discrete, right? Yeah. The weight of bagging on airplane, the discrete. No, wait, you know what the highest weight of my bag? Yeah, yes. And last one is the amount of money like spends per year. I would say, yeah, right? The count. The last one you said was the speed or the first one? Technically, count. Okay, I think we're good.
Did you guys talk? Did you two talk and you discuss this? Yeah. All right. So what do you guys think? Speed of a hurricane. Speed. Do you measure speed or count speed? Measure. So is it discrete or continuous? Continuous. Weight of baggage on an airplane. Do you measure weight or count weight? Measure it. So is that discrete or continuous? Continuous. We'll talk about that a little more in a minute. How about number of pages in a textbook? Do you measure pages or do you count pages? Count. Count. So is that discrete or continuous? Discrete. I mean discrete. Discrete. How about money? The amount of money a person spends. Do you count money or do you measure money? Count money. So is that discrete or continuous? Discrete. Now you might say, but wait, Ms. Young. When I go to an airline and I put my bag on the little scale, it measures it, but it only goes to two decimal places, right? 37.26 pounds or whatever. So it's kind of rounded to the nearest hundredth. So in that sense, you could say, well, since it's rounded to the nearest hundredth on the scale, it's what we call discretizing continuous data. So it's making it, just taking continuous data and forcing it to be discrete by rounding it to a certain decimal place. We're going to talk about that next, which is kind of how we would go about doing that. So we will move on to that. And if you'd said that, then you'd get full. If you explained that part and said, well, it's discrete because it's all rounded to the nearest hundredth or the nearest tenth, whatever, then that would be totally cool. All right, as long as you explain that part. So we're going to talk a little bit about recorded values and boundaries. So say I have a measuring stick and only has whole centimeters. So if I'm looking at 15 centimeters, I would call 15 centimeters anything from 14 and a half centimeters to 15 and a half centimeters. I would just call that 15 centimeters. Do you guys see what I'm saying? So here's 15. Here's 14. We're going to find the halfway point, and everything that's 14 and a half and above, I'd call 15. Everything 14 and a half and below, I'd call 14. Good? So really my boundaries for 15, in other words, what I would consider 15 is anything from 14 and a half to 15 and a half. Anything that comes in that range, I'm just going to, the closest thing to that is 15. I'd call it 15. Those are my boundaries. For 86 degrees Fahrenheit, the boundaries are 85 and a half to 86 and a half. You guys are okay with that? It gets a little bit trickier when we get into decimals, though. The boundaries for 0.43 seconds is 0.425 to 0.435. And for grams, 1.6 grams, one decimal place, The boundaries are 1.55 to 1.65. You will notice that the boundaries have one more decimal place than their actual data. So here, these guys have no decimal places, right? So their boundaries have one decimal place. These guys have 2 decimal places, so the boundaries have 3 decimal places. One more, right? 1 decimal place, these guys are going to have 2. That will always be the case. So let's go ahead and kind of go through these. I'm going to give you guys the easy, fail-safe way to find a boundary. I'm just going to make it simple. So, 15. I need to find the boundary for 15. What's the number that comes before 15? What's the number that comes after 15?
16.
Great. So, my lower boundary for 15, I'm going to find the boundary between 15 and 14. And I'm going to find the boundary between 15 and 16. So this is going to be my lower boundary for 15 and my upper boundary for 14. 14's upper boundary is the same thing as 15's lower boundary. Right? Because if I have, here's my house, here's my neighbor's house. This is the fence that is the boundary between our properties. It's my right boundary and his left boundary. It's the same boundary. Everybody on board with that? So we're going to find it between 14 and 15. It's going to be 14's upper boundary and 15's lower boundary. Same boundary between them. So what's the number between 14 and 15? Exactly in the center?
14.5.
14.5 centimeters. That is his upper boundary and his lower boundary. The other, what's the boundary between 15 and 16?
15.5.
15.5, the number halfway between them. Again, that's 15's upper boundary and 16's lower boundary. So those are our boundaries. You'll notice they have one more decimal place than the regular data. 86. What's the number that comes before 86?
85.
It's the number that comes after 86.
87.
Great. So then what's the number exactly between 85 and 86?
85.5.
85.5. And you could, and it's Fahrenheit, you could, if you wanted to, you could just put them into a calculator and average them if you wanted to. But there's shortcuts for that. Between 86 and 87,
86.5.
86.5. You'll note that really all you have to do is add a 0.5 to the end of this, right? Add a 5 in the next decimal place over. So that's all you have to do. 86, add a 5.5 to it. Add a 5 to the next decimal spot. All right, so then here's where it could get tricky. And this will make it easier for you. Temporarily ignore the decimal place. This is 0.43, but temporarily ignore the decimal place and think of it as 43 for just a minute. What's the number that comes before 43? What's that comes after 43? 44. So 42 before, 44 after. 42, 44. And how many decimal places are there? 2. All good? Make sense? So now you just have to find the number that's exactly between 0.42 and 0.43. So again, the easiest way to do it is just add a 5 to the end of this, the lower one. 0.425. What is that, seconds? And then between these two, take the lower one, 0.43, and just add a 5 to the end of it. Everybody on board? Yeah.
So, like on an exam, if you gave us 0.43 seconds, and how would you want us to answer that? So,
If you
like,
if I asked
exactly
for the
like that?
boundaries, then you would just put 0.425 to 0.435.
Okay.
As long as you have that, you don't have to do the whole thing.
Okay.
Yeah, but you have to have that. I need to. I don't care how you find them.
Just
But-
put the answer.
Yeah. And then this one, 1.6. Again, ignore the decimal place and think of this as 16 for a minute. What's the number before 16? 15. What's the number after 16? 17. So write down 15 and 17. And then where does the decimal place go? It looks like it goes between the 1 and the 6. So pop it in there, right? Number halfway between 1.5 and 1.6. 1.55 grams. And between these two, you can average them in your calculator if you want, or like I said, shortcut, you just add another 5 to the end of the lower one. So why don't you guys do exercises A, B, and C right down here towards the bottom of the page.
Another question. So, how would you want us to write it if we didn't do the
Oh,
extra steps?
we'll
like
get
that?
into that next class, or the
Okay.
class after, don't worry about it.
So just put the two in like a semicolon, like 1.55 and then semicolon with 1.65.
Or put a dash between,
Okay.
just like more like this to
65.
that. Like, no, like a dash, like 1.55 to 1.65.
Oh, okay, right on.
Yeah.
Cool, thank you.
You're welcome. Good question.
Yes. Yeah, 8.55.
8.45.
Yes. So you have to get that way, so I can move on.
Oh, right.
Okay, but yeah. The next one,
Was it 8.35?
do the same thing, this one will be easy.
1.45, and then the second one, 137.
So it's
238.5.
Yes, sir. This one's easy, just analyze it.
So someone asks, well, okay, we'll go to that in a minute. All right, so let's go ahead and take a look at this one. 8.4 quarts. So the number comes before is 8.3, the number comes after is 8.5.
Yep. In between 8.3 and 8.4 is 8.35,
Yep, so 8.35 quarts
and then
to
8.45.
8.45 quarts.
Yeah, so 1.1.
So these are your boundaries. Maybe put a dash in between it, so it's from here to there. Those are your boundaries.
That's how you write that down. Right?
Yeah,
So you have that formula down properly with the writing.
and then here we have, what is that, 138, so it'd be 137 and 139, so it'd be 137.5. What are these? MMHGs?
Don't cry.
To this side would be 130, oops, I keep doing that, 138.5 mmHgs. So that would be your answer there. Good. Because the number between these two would be
Yeah.
138.5.
Yes, ma'am.
Okay. So now we get to the kind of trickier one.
Yeah.
Yeah.
This one here. So 137.63 milligrams. So for a minute, ignore the decimal place. This is 13763. If you're number 13763, what's the number before you? 13762. Everybody on board with that? So ignore the decimal place for a moment.
Yes, ma'am.
13762, and then after 13764. And then figure out where the decimal place goes.
Between the sevens.
Yep. It's between the 7 and the 6. And then find the boundaries. Again, this boundary here is his upper boundary and his lower boundary.
137.625.
Yep, 0.625. Just take the lower one and add a 5 in the end. Milligrams to this one here is 137.635.
635.
Just add a 5 to the lower one. And that would be your answer. Okay? Good. Someone asked a great question, which is, what happens if you got something that landed exactly on the boundary? Where would it go? And the bottom line is, in continuous data, nothing can ever be exactly something. So the probability of it being exactly on the boundary is 0. It's going to be slightly more or slightly less. I will go through that next class.
Because it's infinite, huh? That's why.
Yeah, there's infinite possibilities. So we'll talk about that more next class. But that's the short answer. I don't want to do it today because then you guys will be doing something different than everybody else. So that's not good. So let me ask you this. Are these two numbers the same or possibly different from each other? Yeah, they're possibly different. 14.2 it could be that I rounded. And it really could be that this could be 14.24 or 14.17, I don't know. Right, those numbers, so it could be the same as this or it could possibly be different. What we call this is the precision. This we know to the tenths place. This we know to the hundredths place. This is a little more precise. So here, we know this is true to the hundredths. We know this is true only to the tenths. So let's talk about significant digits. Significant digits, to find how many significant digits you have, you go along to the first non-zero, that'd be this one, and you start counting. 1, 2, 3. This one has 3 significant digits. This one, though, has 1, 2, 3, 4 significant digits. So this one's more precise. It has 4 significant digits. Okay, don't worry about it that much. We're going to get back to that in chapter 3 when we start really getting into that stuff. But I just want to give you a little preview now while we have it here. All right, let's talk about levels and scales of measurement. How about, let's flip to the next page. Stephanie J., go ahead and read.
Nominal, categorical, names, color.
Oh, yeah, sorry. Keep going.
Oh, names, color, gender, jersey, ordinal, nominal plus can be ranked, order, birth order, finish of race, letter grades, interval, ordinal, plus intervals are consistent, no true zero, ratio, interval plus ratios are consistent, true zero, below which no values exist.
Yep, perfect, thank you. All right, so nominal, everything is at least nominal. It's where things don't have any order. So, color of hair. Is red ranked higher than black or ranked higher than brown? No, they're just all hair, right? There's no rankings. That's nominal. Or names. Is John ranked higher than Stephen, ranked higher than Janet? No, they're all just names, right? So that's nominal. Jersey, no, we talked about jersey numbers already. Nominal. Ordinal is when they have an order to them. So like small pizza, medium pizza, large pizza. The large is bigger than the medium, is bigger than the small. So those have an order to them. Letter grades are ordinal because there's this range of A and there's this range of B. So the difference between a B and an A might be this much, or it might be this much, depending upon where the B is and where the A is. So that's not consistent. Interval is when the intervals are consistent. So, for example, degrees Fahrenheit, that's a good one. So the difference between 10 degrees and 20 degrees Fahrenheit, that heat difference, that energy difference, is the same amount of energy as between 60 and 70 degrees Fahrenheit. It's the same amount of energy you have to put in to raise that water 10 degrees. So it's the same. If we talked about grades in percentages, the difference between getting a 20% and 30% on the test is the same as getting between a 40% and a 50% on the test. So grades that are numerical like that, percentages, those would be interval, right? Because 1 point on the test is 1 point on the test no matter where it is, right? Okay. Ratio is where the intervals are consistent, but there's a true zero. So for example, if we look at interval, 0 degrees Fahrenheit does not mean no temperature at all. 0 degrees Kelvin, who's ever heard of kelvins? 0 degrees Kelvin really means no temperature, no energy at all. Right? That's a true zero. If I have 0 degrees Fahrenheit, I don't have no temperature. It's just, it's cold. It's quite cold. But, you know, it could definitely get colder. But with ratio, if I am 0, if I have a height of 0, I really have no height at all. If I am 0 years old, my age is 0, that means I was just born. If we're talking like continuous, like every second and fraction of a second counts. If I am 0 years old, I was just born right then. If I have $0 in my pocket, I really have no money at all, right? So 0 really means 0, none. That's the ratio. I don't want to spend a ton of time on this because it's really not super important, but I have to cover it because it's in the course outline. So let's take a look at this one. And just with your neighbors, take a minute and try to figure out which one each of these is.
Yes. Or, not yet, no. Letter grade? What she said. That would be ordered. Yeah. Because that's just like like the ranked. The F is what's the same. ACT scores. I think that was the interval. Yeah. See, that one is like a test. 2 points on test, sure. It doesn't matter where it is. It's 2 points. What's that? Yeah, like just 2 points. Like on enemy test scores. And then height. Yeah, height. Yes. Which one's 0? Height. Yeah. So that's just it.
I guess it's not ancient.
Right.
Okay.
Yeah. Yeah, so, yeah, we'll talk about that in a minute. So, hair color. Is hair color ranked?
No.
No, so it's just nominal.
Yep.
Zip code, is that ranked?
No.
No, so it's also just nominal. Letter grade, is that ranked?
Yes.
Yes. So it's at least ordinal. Is the difference between an A and a B always the same? Is it? No. So that's going to be just ordinal. Everybody on board with that? ACT score. So that's like SAT score. Someone's talking about that. Can you really get 0 points on an SAT score? No, you can't. I think the lowest you can get is like a 200 or something like that. What was that? No? If you answer nothing, I think you get like 200.
Yeah. You get 200 for writing.
Yeah, I mean, just, right? So ACT score, I think, is a similar thing. So first of all, are ACT scores ranked? Yes. So if you have a 34, it's higher than a 27. Is 1 point, is the difference between a 26 and 27 the same as the distance between a 30 and a 31? Yeah, I think it is. That seems like seems true. But they don't have, I don't think you can get a 0 on an ACT score. Does anybody know about ACT scores? No, yes? I'm going to make the statement, you cannot get a 0 on an ACT score. And you guys wouldn't know the difference because you guys don't know anyways. But no, I'm telling you, you can't get a 0 on an ACT score. So does it have a true 0? No. So that's going to be what? Interval. We all good with that? Mm-hmm. Height. Can you rank heights? Oh, can you rank heights?
No.
Is someone who's 6'2", are they taller than someone who's 5'11"?
Yes.
Yes. So there is a ranking to it. Is the difference between 5'1" and 5'2", the same as of exactly 5'1" and exactly 5'2", the same as the distance between 5'6" and 5'7", exactly. Yes. So is it interval? Yes. Does a height of 0 really mean no height at all? If I'm 0 height tall, am I really no height at all? Yes. Everybody good with that? Okay. Obviously, somebody can't be 0 height because they would be dead, right? But I mean, but something could have a height of 0 theoretically if it was maybe like a laser plane that had no width at all in some way. Anyway, let's not go there. So height ratio, age. Is someone who's 24 older than someone who's 27? I'm sorry, someone who's 24 older than someone who's 19?
Yes.
Yes. Is the difference between being exactly to the millisecond 15 and being exactly 16 the same distance as being exactly 27 and exactly 28? Yes, so it's interval. Is having an age of exactly 0 meaning you have no age at all? Yes. So which one is it? Ratio. Temperature Fahrenheit. Is 85 degrees Fahrenheit hotter than 70 degrees Fahrenheit?
Yes.
Yes. So it's ordinal at least. Is the distance between 60 Fahrenheit and 70 Fahrenheit the same amount of energy you put in to get from 30 Fahrenheit to 40 Fahrenheit? Yes. So it's interval. Does 0 degrees Fahrenheit really mean no temperature at all? No. It's just a marker. You can go all the way down to kelvins. 0 degrees Fahrenheit was just a random number they picked to indicate where water. No, wait.
Yeah, 0 degrees.
No, it says Celsius where water freezes.
Okay, it's 32.
Yeah, what's 0 Fahrenheit? It's just cold. Okay.
It's easier to comprehend.
All right. Fair enough. It's just some random arbitrarily picked number. So that would only be interval. Everybody on board? Okay. Here is that whole thing prettier. You want to see it prettier? Now we're going to talk about data collection and sampling distributions. So first off is random. Random number generator, if you use that, and you randomly pick people from the population. Every single person in the population has an equal chance of being selected with a random. So that's the best and ideal situation, but not always possible. And let's talk about systematic. Gauge P, read just the new one, this part right here.
Systematic, every kth subject. For example, sample obtained by picking every 20th customer, starting randomly with a number from 1 to 20. So 3, 23, 43, 63, etc.
All right, so the first one's random. If I want to pick every 100th customer, I'm going to randomly pick a number between 0 and 100, or 0 and 1 and 100. So I pick 42. So I pick the 42nd customer, I pick the 142nd customer, 242nd customer, 342nd customer. Right, so it's systematic. Everybody on board? That way you don't, if you just take a bunch of people, then you might get some people who are similar in traits if they're too close to each other. Okay, next one. Brandon, W. Strasser. Just read the new stuff. It's right here. Example? Right. Have you guys ever seen stratified rock? It's rocks that are kind of layered, right? So it's like you pick some from each layer. You might say, oh, Las Positas, I want to sample everybody here. So I'm going to group all of the students together. I'm going to group all the faculty together. I'm going to group all the administrators together. I might pick 100 students randomly. And then I might pick, well, there's fewer faculty, so I might pick 10 faculty randomly. and there's fewer administrators, so I might just randomly pick 2 administrators. So then each group is represented, but maybe not equally. Or maybe they would be equally. So maybe I might have my Facebook friends, I have my soccer friends, I have my school friends, I have my poker friends. And maybe I pick 4 from each group, right? So each group is represented. They can be equally represented or not, depending on how you do it. But stratify means you split them into groups and you pick some from each group. Next one, how about, oh, I just dropped. Ashley, L.
Cluster, use only randomly selected groups. Example, to survey all California community college students, randomly pick 10 colleges and randomly survey students there.
Perfect. You can also have convenience, where you survey a convenient group. So I want to know about teenagers, so I go where there are teenagers. I go to the mall to get teenagers. Or self-selected. I use those who volunteer to respond. Why are these last ones light blue? These two, like these respond to it. Talk to your neighbors and see if you can figure out why they're light blue. 30 seconds. Talk about it.
Oh, because they could become biased. They're not unbiased. It's just subject to. Because you're looking for